Hi, Tristan. Good morning. For me, good evening to you over in France.
Hi, Red. What's up?
Not much. How are you doing this Friday?
I'm doing good. Weekend is coming. Unfortunately, summer is ending now in France, so it's getting quite cold now. But I'm doing good. What about you?
Doing pretty well. It's been a bit busy, productive summer for me, and it's been, I think, a year and a half ish since you've been on, maybe 2 years.
Yes, I think it was 2 years ago. A topic on Power BI aggregations and yeah, building big data models to analyze the New York taxi trips. Yeah.
Yes, yeah. Using the egg tables function in Power BI to pre-aggregate to speed up models and everything. Yeah.
Yeah, exactly.
Yeah, and I think as we were just talking too, the video has, as you said, like what, 7,000 views at this point.
Yeah, I think even more. I think 8K or 9K, and
Nice.
lots of questions also after the live. Like I saw the comment. I even discovered yesterday some comments and questions that we haven't answered. So probably we
Oh,
need to.
okay.
Yeah.
Yeah, I try to be on top of it. Anytime there's a live stream question that's something I can't answer, I'll usually ping the guest, whoever that is, and like ask them to answer that. But
Mhm.
um, yeah, feel free if at any point if you ever see one of those, just go ahead and like chime
Yeah.
chime in on that. But I'm usually pretty good on being on top of those, unless I'm on vacation for like 3 weeks and it gets lost in my email thread. But
Yeah.
I'm glad to have you back on. I think certainly it's going to be a good topic today on modeling, because I know a lot of people are always confused on like power query, column, measure. Where do I put my business logic? For something that needs to be calculated or math that needs to be done. So anytime that we can help provide some clarity for people getting started and kind of learning the best best place to park certain things that go into the modeling to a degree is very helpful to get onto the channel, and helps to, I think, remove a lot of that gray area and confusion on what to do and where for individuals. So I'm excited for this today. But with all of my streams, what I like to do is give you a chance to introduce yourself a little bit, and give the channel a chance to get to know you a little before we actually get started on the topic, if you want to start there.
Yeah. So first of all, thanks for having me again. I'm happy to be here with you today, Reed, and to share this to your community and to the Power BI community. So I'm Tristan. I'm French, and I'm running a consulting and training company called Data Pulse. So we mainly consulting and training services around Power BI and more. I also created the French Power BI user group, which is called Club Power BI. It's 7 years old now, and we have more than 7K members already. A lot of content online. We have a YouTube channel, a forum, and so on. And more recently, beginning of this year, I started a new user group, which is separate. We decided to split the user groups in France between Power BI and Fabric. I'm wearing the t-shirt now, the Club Fabric t-shirt,
Nice.
which is our new user group. It's much smaller, obviously, because Fabric is new and the Power BI and the community, sorry, is still discovering this exciting product. But yeah, and yeah, last, I'm an MVP, Microsoft Data Platform MVP, since 2017 already. So already 7 years, mostly for my Power BI and Fabric contributions now. Yeah, so that's it about me.
It's crazy to think it's been like, because when was my first ship? 2018 to 2019 is the, so you got yours a year before I because you're
Yeah,
17 to 18, right?
yeah, exactly. Yeah. To
I
be
I
to
will
be to be accurate, I think I was the last year where it was not 18 19 or 19 20. It was like a full year, like 17 16. Before it was like that, so I was 17, and then they shifted to
Oh
these
yeah,
2 years. Yeah,
the window, yeah, to make it more
yeah, the
clear. I was like,
window.
no, no,
Yeah.
no. Yeah, no, yeah, you can't have a single date, you have to have a date range.
Yeah.
Exactly.
Yep.
But also coming on to the topic of the day today. So the broad discussion is just, of course, DAX calculated columns, but within that, in practical use cases, where do you want to start on kind of describing what we'll be getting into today?
Yeah, so basically the goal of this session is to show you that DAX calculated columns sometimes are a good idea, and we will see when and how and what. We will talk about performance, data modeling strategies, obviously all these discussions about where should I put my business logic, and should I do it in SQL, should I do it in Power Query, what about DAX measures? Like, people are asking a lot of questions in the community or my clients about this. So the goal of this session is really about giving you some insights. Maybe you will not agree on everything, and that's the beauty of Power BI. It's that sometimes you have multiple solutions to the same problem, and it's not necessarily the best solution which wins, but the most adapted to your need. So yeah, we will see this now with many practical use cases and concrete demos. I'm gonna demo and code everything live from scratch. So very risky for me.
Where's you need some wood to knock on.
Yeah. So yeah,
Well,
Rita, I
whenever
think
you're
I'm
ready, I
ready.
can.
So,
Yeah,
yeah,
whenever you're ready, I can flip over.
let's go.
Here you are.
And yeah, for the people on the chat, feel free to ask questions. Unfortunately,
Mm-hmm.
I only have one monitor today, but I have access to the chat on my phone. And Reed, feel free to interrupt me if you have any good questions on the chat. Okay.
Absolutely.
So this session is really about DAX calculated columns, but obviously I will also talk about other things. I already presented myself. So the agenda for today, first, I'm going to give you a bit of context about why I decided to submit this session. Second, I will show you and we will discuss why DAX calculated columns can be bad. There are many reasons. And then we will explore together many different use cases about DAX calculated columns, where can they be relevant, what can they bring in terms of performance, etc. So I've been in the Power BI community for many years, and I tweeted this actually last year. It was almost 1 year ago now, October last year, this controversial opinion where I said on Twitter, beginners used a lot of DAX calculated columns for wrong reasons. That's what I was doing at the beginning of my Power BI journey. Then intermediate users, they understand that sometimes they can be bad, and then they try to never use DAX calculated columns at all because they heard it's super bad. And then advanced users use DAX calculated columns in specific and relevant scenarios. And based on this tweet, there were many reactions on Twitter, many threads, sub-threads, replies, questions, debates. And you know, I'm French, so obviously I love debating, and I love trying to illustrate my point of view. So this is why I decided to submit this session today, because there is a lot of debate in the community, in the Power BI community, about the use of these DAX calculated columns. Obviously, this tweet was a bit provocative. It was also to provoke some reactions, and actually it was successful because there was a lot of reactions, and I think it's an important topic, and we will try to discuss it today. So the first thing is, I'm going to start by the opposite. I'm here to show you that DAX calculated columns can be good, but first we're going to talk about why they have such a low popularity in the BI and Power BI world. Well, first, as you probably know, unlike DAX measures, DAX calculated columns are persisted. They are stored in the data model, and they only recompute at processing time. So they do not recompute on the fly. They are stored in your data model, like DAX calculated tables as well. So this can have technically a negative impact on your Power BI data model processing time. So when I say processing time, I'm obviously talking about the refresh time, both in the desktop or in the service, and also the size of your PBIX of your model. And most of the time, DAX calculated columns are used for wrong reasons, like especially people coming from the Excel world. That was my case a few years ago. I was really interested in DAX calculated columns because it would remind me my Excel experience. And I was using a lot of DAX calculated columns instead of measures, for example. So that's probably one of the the wrong reasons why you should not use DAX calculated columns. But sometimes to answer your BI questions and to answer your needs coming from your manager or your clients, you actually need to add columns into your model, right? And the thing is, there are multiple places in your project where you can technically add those columns. There is this sentence, this maxim from Matthew Roach, who is in the Power BI slash Fabric customer advisory team now. And he wrote a blog post a few years ago where he said, data should be transformed as far upstream as possible, and as far downstream as necessary. And it is totally true. I completely agree with that. When you add a column, you actually reshape the table, and it's definitely considered as a data transformation, right? So you should always follow this kind of mindset. If you can do it upstream, which means probably in Power Query or in your data warehouse, if you have a data warehouse, then it's better, not only for performance, but also for governance purposes. The problem is, unfortunately, I have to say, not all Power BI projects have a data warehouse or a SQL layer. Okay, it's not always available because maybe your company is not mature enough. Maybe you don't have data engineers, or sometimes I have faced this situation multiple times. Companies do have a data warehouse, but IT and data engineers are not available to add those columns or to apply those transformations, not short term. They might be available in 2 months, but you need your report in 2 weeks. So how do you do then? So when you don't have a data warehouse, or when the IT or data engineers are not available, you can teach yourself how to use SQL and stuff, but let's assume that you can't, or you don't have time, okay? So what are the alternatives? You can, of course, you can use Power Query and the M language, because of course, in Power BI Desktop, you have Power Query and you can technically add columns into the model. The problem is, I'm sure you have already experienced this before, Reid, sometimes when you add columns using Power Query, it's not very easy nor performant. Some DAX is sometimes better and faster to execute, and we will see a few examples in the rest of the session. But yeah, so you should always follow this logic, do it in the data warehouse. If you can't, do it in Power Query, unless some specific scenarios that we are going to cover today. I see that some people in the chat say lazy IT not available for 2 months. Well, sometimes it's even more. Huh? Sometimes it's 6 months. Okay. So
well, then it's not always, I would say, lazy. Just like sometimes it might be an understaffed IT staff of 2 that's trying to do the job of 20 people. Just because they don't give them enough resources. Yeah.
Exactly. And the whole mindset and the whole spirit of I think one of the success of Power BI is that it was open to business users, and they could explore possibilities and ways of doing calculations. And DAX calculated columns are part of this journey. So now we're going to try to see a few use cases where we're going to assume that you don't have a data warehouse, and we're going to assume that you both know Power Query and DAX, but you hesitate between the two. Okay. So to illustrate my point, I'm going to switch to Power BI Desktop. And I'm going to use this very simple star schema data model with a fact table with 2 million rows and a few customers, stores, products, and so on. So my data model respects all the Power BI best practices, and I'm going to use it. All my demos will be based on this data model. So the first example which comes to my mind when it comes to creating DAX calculated columns, it's to do what I call static segmentation. So for example, let's assume that you want to classify your customers. So this is the customer table. I have the customer key, the continent, gender, and so on. It's obviously linked to my fact table through the customer key. And let's assume that you want to classify your customers based on a DAX measure. So in this model, I have a DAX measure, which is called total sales year to date. So it's pretty straightforward. Let me zoom this a bit. So it actually performs a year-to-date sales for this KPI. So this is DAX measure, which recomputes on the fly. Sometimes you want to use DAX measures in order to apply rules, segmentations, and groups, okay? So why, in this case, would I use DAX calculated columns instead of Power Query? Because unlike Power Query, DAX calculated columns can leverage the data model. They can leverage the relationships between the table, and they can even refer and call existing DAX measures in your PBIX, in your model. So this is what I'm going to do here. I'm going to simply add a column. I'm going to do a very simple stuff. I'm going to add a column. Let me zoom this a bit. I'm going to call this customer group. And I'm going to say if total sales year to date is superior to 500, then high, else low. So this DAX calculated column is persisted in the model. It's using the DAX measure total sales year to date in order to compute and to classify each customer. So yes, it is supposed to be bad because I am adding a new column to my model, but the good news is that this column has a very low cardinality. The number of distinct values of this column is actually 2. And as you probably know, the Vertipack engine compresses pretty well the columns which do have a low number of distinct values, even though these columns are DAX calculated columns, okay? So in this case, I am adding a classification. I could not have done this very easily in Power Query because it's pretty hard to compute the year-to-date and stuff in Power Query. The Power Query was not built for that. So thanks to DAX, I can refer to my DAX measure and I can classify my customers. This is just an example, right? And then, of course, I can use this DAX calculated column, which I can recognize with this icon as part of my visuals, and obviously everything recomputes on the fly. So for example, if I want to recompute my total sales by customer group and by country, of course, it recomputes on the fly. Here, I'm combining the power and the beauty of DAX measures and DAX calculated columns in order to classify my customers. So this is one example. Yes, technically, it would not be easy, but technically, you can do it in SQL. But again, you don't always have access to SQL. Technically, you could do it in Power Query, but I don't know, Reid, if you have already tried to compute year to date and stuff in Power Query, this is a mess, right? It's very hard, right? So
exactly. And the one of the other things that I'd mention along the lines of this too is because this is something that technically could be a measure. So it really boils down to, is this going to be used as a slicer or on the filter pane as well too? Because you're mentioning like adding columns isn't bad. Like generally adding columns to a fact table is what you want to try to avoid. Fact tables should be tall and narrow. Its dimension tables can be wide, but I have this exact situation sometimes where I just have a detail table for customers that's on a page, like a matrix table. If the only place this flag is ever needed is just to have like row by row, just show a customer and the label, you could put that into a measure. But as soon as you need a slicer, as you shown, very easy to compute, easy to add, just right onto the table. And the other nice thing that actually I think encourages people to use shared data sets is like a lot of people will sometimes try to do this in Power Query because they hate to see the icon. They don't want to see an extra icon in the local model. But as soon as you start doing a shared data set and you connect live to it, all those extra symbols go away. You can't tell the difference between where the column was added. It's just a model column. It's only showing in the local. Yeah,
of course. Yeah. So, Reid, I think you have just spoiled half of my session. No, I'm joking.
It's good topical things to discuss during some of these, right?
Yeah. But yeah, so actually you made a good point. Here I really needed this column because I want to be able to use it as a filter or as an axis. So it cannot be a measure because I want to use it as an axis, as a way to break down my sales or whatever. So that was one first example, which was pretty basic. Okay, pretty basic one. Now we're gonna increase the level much more. Okay, So let's see a second example, which is much more advanced, but very interesting. So again, in the same model, there is this need sometimes, especially in marketing, where you want to compute the number of new customers. And it has to be recomputed on the fly, like by year, by month, by product, by whatever, right? So actually the Italians that you probably know, all of you, Marco Russo and Alberto Ferrari, they have coded this DAX pattern, which computes on the fly without using any pre-compute, without using any SQL statement, Power Query column or DAX column. This is purely a 100% DAX measure solution, which perfectly works, and it computes the number of new customers. And it's great. But as you can see, the code is pretty difficult, right? Not everyone would be able to code that or to understand it. So we have this DAX pattern, which is working very well. And it returns dynamically the number of new customers by year. And of course, it recomputes on the fly. Here, my data model is pretty slow. It's pretty, small. So the performance is quite good. But you could face some performance issues even with this pattern as you get a big number of customers and transactions in the fact table. Now, I'm going to show you how you can actually optimize the performance of the report by computing the same KPI, so new customers, but differently. And by differently, I mean by pre-computing some stuff in the backend, in the customers table in this case. So let me show you this. I'm going to go to the customers table. Again, the same. This is a dimension table. So this is okay. I'm not in the fact table. I'm in the dimension table. And what I'm going to do, I'm going to add a new column which pre-computes for every customer what is the first date of the transaction. So I'm going to call this column first purchase date. So this is a DAX.
And honestly, a lot of databases have this too. Like this is a column that even without DAX is not uncommon to have in a customer table.
That's true, but let's assume that we don't have it here. Okay, so if I do this, because I'm in a row context, I'm not going to do a full course on DAX. That's not the topic of today, but because I'm in a row context, I'm in the calculated column, the engine does not understand that it has to recompute this order date, this minimum order date for each customer. To do that, I need to invoke context transition. I need to transform my row context into my filter context. And how do I do that? By applying a calculate. And because there is a relationship between customers and sales, calculate allows me to travel and to navigate through the relationship. And then it allows me to pre-compute what is the first purchase date, the first order date for each customer. Okay. Actually, I can hide this column. I don't necessarily need to expose it in my data model, but then I'm going to use this column to compute my new customers. How do I do that? First, I'm going to create a relationship between the calendar table and this new column. Because I already have a relationship between calendar and sales, I cannot have an active relationship between calendar and customers. Otherwise, I would have an ambiguous model. So what I'm going to do is that I'm going to turn it inactive. Okay. As some of you may know, you can leverage the DAX language in order to say, I don't want to go through this path. I want to go through this path. Okay. This function is called use relationship. So I'm going to use it right now. Before I do this DAX measure, just a comment. Some people might say, yeah, but technically you could do this in SQL. That's true, by doing a join, or you could do it in Power Query and M by doing a join and then taking the mean. But again, if you do this kind of thing with Power Query, first, it's not that easy. I mean, in my opinion, it's more difficult than this code. And because the Power Query engine is not the best to travel between tables and to do some joins and stuff like that on big tables, usually you will find it that it's actually not only easier but faster to do this kind of calculation in DAX with the use of DAX calculated columns. So that was just a comment about why I decided to do a DAX rather than SQL on M. So now, how can we reuse this DAX column in my measure? So I'm going to create a new measure. I remind you the goal is to compute the number of new customers, and obviously I need to return the same amount, like the same result as the pattern from SQL BI. Okay, so new customers, this is going to be my measure. I'm simply going to say calculate count rows customers, and then I'm going to say use the relationship between the order date, between the calendar, sorry, and the first purchase date. So this is what I'm doing in order to compute the number of new customers. As you can see, you can reuse your DAX calculated columns in your DAX measures. This is what I call a hybrid measure, like a measure which reuses business logic and DAX calculated columns, in this case, from other parts of the model. Okay, so here that was the DAX calculated column that I pre-computed. Okay, so I format this, I put it in my chart, and it works, hopefully. So as you can see here, we have two problems. Let me show again the code. First, so the values are the same, but you can see that the first problem, I have customers which are attached to blank, like no years. We're going to understand why. And the second issue with this code is that because I am counting something which is here, the problem is if I try to filter, for example, by the country of the stores, you will see that my DAX measure does not take into account the filter coming from the store table. Okay, so I'm going to try to fix both problems. The first problem is actually because the blank, it's because I have some customers in my dimension table which do not have any transactions. I can see them here. For example, this one, it didn't find any date because it doesn't exist in the, probably there were transactions in the very past, but in this data model, this customer does not have any transactions. Okay.
Yep.
So let's try to fix this. I'm gonna actually comment, my code. And then what I'm gonna do, I should have copied first, but anyway, I'm gonna do this. And then I'm simply gonna use the expanded table feature, in DAX, where actually I will just refer to my sales table. So by doing that, I'm fixing both problems. Now, not only I remove the blanks, but also, as you can see now, my DAX measure recomputes on the fly by taking into account any filters coming from my data model. So I am perfectly matching not only the results, but also the behavior of the new customer SQL BI pattern. But as you can see, it's pretty slow. Like now I don't have any filter. It's pretty slow because this technique of using the sales as a way to propagate the filter is very costly because usually DAX doesn't like when you refer the whole table. So actually, let's optimize this pattern. What I'm going to do, and I think this is one of the thing I like the most about DAX calculated columns, is that you can actually use them as flags also in your fact table. So what I'm going to do now is that I'm going to go to the sales table, which is the fact table, and I'm gonna simply flag using another DAX calculated column. I'm just gonna use a flag to say, okay, this transaction in the fact table, is it the first transaction of this customer or not? So how do I do that? Flag first transaction. So here I am using a DAX calculated column in the fact table. And I see you coming. You're gonna say, no, Tristan, don't add DAX columns in the fact table. Be patient. I'm gonna get there. Okay. So first I'm gonna create a variable which is the first transaction date. So actually here I can do a related, and this is one of the good things about DAX calculated columns. Again, they can leverage your data model. So you can actually get results from other tables if they are related, thanks to the related function, without doing any lookups or complex joins that you would do if you were to do it in Power Query. So here, I'm just gonna bring in the first transaction date. Then this is gonna be my transaction date. I'm gonna use the row context here. Okay, and now what should I do? I'm just gonna compare these two. I'm gonna say, is the transaction date equal to the first transaction, which I pre-computed from the dimension table? So this is gonna return a Boolean, true or false, and this pre-computes, is it the first transaction for this customer or not? So let's take an example. For example, let's take this one, just for you to understand. Okay, so I have this customer. Let me sort ascending. Great. So as you can see, this customer has transactions here and then here. It returns true for all the transactions at the same first date, which was the 14th of July, totally chosen randomly. This is the national fête nationale in France, but anyway. And this is false for all the other transactions. So by using two DAX calculated columns, I can know for each transaction in the fact table, is it the first transaction or not for this particular customer? So actually, I'm gonna hide this flag. Okay. And then what can I do? Well, it's very simple. Now I've done the worst, I would say. Now what I'm gonna do is that I'm gonna shift this. I'm gonna say distinct count. So now I'm gonna do a distinct count on the fact table. Okay. And I'm gonna use my DAX calculated column as a way to filter the data. I don't even need to say equal true. Okay, this is implicit. When I say this, it's just equal true. So now with this DAX measure, obviously I get the same results as before. So this is the same result. Obviously, again, it recomputes on the fly based on any attributes. But, and this is the most important, why did I do all of this? I spent 10 minutes creating columns and doing complex stuff. Well, complex, I don't know. But the thing is, believe me, and I'm going to show you how, and we're going to measure this in a few seconds. This pattern is 5 times to 10 times faster than the full DAX measure solution. So be careful. Huh? I am not criticizing SQL BI or Marco Russo or whatever. There is a reason why in the patterns they do it only with DAX measures. It's because they want this to be like fully recomputed and they want this to be a pattern, right? But in this case, by pre-computing the DAX calculated column, I have much better performance. So let's see this in action. But before that, before you understand the impact of this DAX calculated column, I need to introduce you to a concept. And this is the most important part of the session. I need to introduce you to the concept of the magic triangle. So actually, when you work in Power BI, you make decisions like, do I add a column? Do I add a measure? And so on. And you always take decisions within this triangle. The front end, the back end, and the data model size. So the front end is actually the performance and interactivity of your report. It mostly relies on the quality of your model and your measures. The backend is actually the processing time of your Power BI model. It relies on the data volumes, architecture, infrastructure, and so on. And then you have the data model size, which is actually the size of your model, which relies also on the data volumes and cardinality of columns. Most of the time, like 95% of the time, where are the most important expectations? The most important expectations are in the front end. Your end users, they want to have fast and interactive reports. So these are the decisions that you take in Power BI. Shall I maybe give advantage to the front end or to the back end? Shall I pre-compute stuff in my SQL layer? Shall I do this in DAX measures, in DAX columns? This is all about this triangle. And it's very hard to optimize the three sides of the triangle at the same time. You always need to find the good balance between what you want to do at the front and what you want to do at the back. Okay? So in this particular case, let's analyze the magic triangle with the new customers pattern. So first, the data, what is the impact of adding my two columns on the data model size, which is one part of the triangle? So to do that, I'm gonna use DAX Studio, external tools, DAX Studio, and I'm gonna be able to scan the properties of my model and especially the size of each object in my model, my tables, my native columns, and also my DAX calculated columns, because they are stored and they are persisted in my model. So I'm gonna apply view matrix, and you will see that the two columns that I have added, which are the flag first transaction, this one, it represents less than 1% of the size of the model. So what is the impact? Nothing. Nothing. It's less than 1%. It was added in the fact table. It represents less than actually 0.05%. And why? Because it has a very low number of distinct values. Okay? The same for the customers. The first transaction then, which was my DAX calculated column, the same. Less than 0.5% of my whole model. So what is the impact on the first side of the triangle? Nothing. I have added less than 1% of the model. Okay. What is the impact on the backend performance, like the processing time of my model? Very low impact. As you probably saw, when I have created here, I have the whole model, like the 2 million rows. When I have added my columns, it took 2 seconds to compute, because DAX is very fast, even for DAX calculated columns. So in this case, the impact for the magic triangle on the backend performance, the impact of these two columns is also very low, very low. So to summarize, I have added two columns. It only increases by less than 1% the whole size of my model. And maybe it's gonna increase by 5 seconds or 10 seconds the processing time of my Power BI data model. So I think it's okay, right? It's not too bad. Now, let's analyze the impact of the front-end performance. Like, I want to measure if these calculated columns actually bring a better front performance. So to do that, I'm gonna use DAX Studio, the same one. I'm gonna go to the Home tab. Actually, I have already copied my, So I'm gonna use this DAX query as a reference to test the performance of my two measures. So this query actually returns the number of new customers and breaks it down by a few dimensions. It returns 19,000 rows, just as a way to benchmark the performance of both measures. So to do that, I'm gonna go to results, log timer, so I can focus on the not on the result, but on the time it takes to compute. And I'm gonna clear the cache every time I run my query so that I can compare it. So let's do that. I run my query. And as you can see, It's scanning. Well, it took 7.8 seconds. So when I was doing this test without the YouTube and Skype live, I was more around 3 or 4 seconds. It's also because of the live and the setup, but that's okay. Let's use this as a reference. I'm gonna do it a couple of more times so that we can have like a median or average. Oh, you see that now it's a bit better, even though I cleared the cache. 4.5.
There's always variability sometimes too, just depending on like how much your computer is being used and whatnot.
Okay, so 4.5, 4.7. Okay, this is milliseconds. Okay, so let's say 4.6. Okay, seconds. 4.6 seconds. Okay. So Reid, in your opinion, how much time is it gonna take now? My measure. So now I'm gonna run the same query, but this time using the DAX measure, which leverages the DAX calculated columns that I pre-computed. In your opinion, how long is it gonna take?
It'll probably be milliseconds. I'm sure it'll be less than a second for sure.
Less than a second. Let's do it again. 800 milliseconds, so that's less than 1 second. So in this case, I have optimized by 4 times the performance of this measure. So you're gonna say, yeah, but you will not break down every time at this grain. Okay, this is just a benchmark, right? You could have different performance gains depending on the grain of your analysis, but that was just an example to show you, like in this case, and just to recap, in this case, by adding two DAX calculated columns, my data model size plus 1%, my backend performance plus 5 seconds. I think it's okay, right? In 99% cases, no one will notice this impact, okay? But the front-end performance, 5 times better. Wow, agreed. That's amazing, because this is where business users expect me to perform, okay? This is what they see, actually. This is the report, like this is the interactivity of the report. So as you can see here, by using DAX calculated columns, I have actually used the beauty of the magic triangle in order to optimize my front-end performance. So that's just an example, right? What do you think, Reid, about this example?
Well, and to your point of the adding columns as well, and where is the number one perpetrator of size is cardinality. Like at one point, I remember for a customer, I had to build a rollover security table that was 468 million rows. It had a combination of employee ID and I think, let's just call it division ID. So each one of those only had a few thousand, but it was a many-to-many. So that table added 26 megabytes to their file at 450 million rows. So adding flags to a fact table is fine. If you have a binary column, you could have a billion row fact table. If you added a true false column to a billion rows, you'd maybe add a couple megabytes, but your model's probably like, multiple gigs. So you're still adding incredibly small amounts like that. So I think it is often advised, it's advised to avoid any extra columns on a fact table when you don't truly need them, but basic flags to help pre-filter data, rather than having to do the math on the fly, is very useful for new customers. Certain flags that don't need to inherit additional slicer filters that are coming from the report configurations where like, well, maybe I want a new customer, but I also want to know, depending on, which region, maybe a customer is, going to be new in the East region, but not in the Central, depending on my slicers. You might need to do some more stuff in measures, but I think your point's perfectly proven on. It's fine to add them at this level when you have such few additional calculations. You're not adding a unique value per row. It really just shows the power of the Vertipack engine and the fact that rows are almost irrelevant to a degree. It's really the number of unique values that has to be cached and stored in in memory.
Exactly. Here, and this is the beauty of the Vertipack engine, as you say. It compresses very well the columns which have a very low distinct number of values, so a very low cardinality. And this is why, in this case, even though I'm adding the flag transaction, first transaction in the fact table, it's okay. Then there is another debate, which is obviously maybe some people in the chat will say, yes, but technically you could have added this in the backend in SQL. Yes, always yes.
Sure.
Technically, yes. But again, sometimes you do not have a data warehouse, or the data engineer is not available. And what are you going to do? Are you going to wait 6 months? No, you want it now. So here you have solutions which work, which increases the performance of your report, and which do not have any major impact on the two sides of the triangle, which are the data model size and the backend performance. So
you could also do both. To your point of IT on this, like, so Power Query and DAX do offer short-term solutions for a long-term goal. So if this is something that does need to be moved upstream and it's going to take 6 months, ask. Oh, God damn it.
Yeah, exactly. Really.
Ask IT to add
Reusability, as you said at the beginning of this stream. If I connect, maybe I will do it at the end if we have time. And now I have other demos to show, but just a comment. If you connect to this semantic model from Excel or Power BI, you can use these DAX calculated columns as if they were native columns. So in terms of reusability and self-service BI, it's okay. I mean, they are here and you can use them. Okay. So I have a couple of more examples to show. That was the most advanced one. I went very. I dove into the Vertipack engine, and so maybe that was not easy to grasp for everyone, but still I hope it was clear. Now I have other examples which are also very interesting, I think. So I'm just checking no questions on the chat. Someone is saying that they use the SQL BI pattern in 30 reports and they will have a look at the, okay, yeah, try it.
Oh, and just one other comment to your thing as well, and like when to like add a column versus a measure, is you kind of have shown, like, I mean, if you are calculating new customers, you know, and you've used that on your report pages and it's taken under a second everywhere, there's no need to add the extra column. But it depends on size. Like if you have 100,000 rows on a fact table, you can do some stupidly complex things in a measure and you're probably still going to be fine in that. But as soon as you hit 10 million, 20 million, it starts to slow down. Maybe compartmentalize out as you like pre-calculate some of those things that you need as a flag. But it goes to that it depends. And like, you know, when do I move upstream to a degree my logic? When things start to get slow. If things aren't slow, try it in a measure first, then consider the other steps of the columns or wherever else you need to put it.
Completely agree. Whenever you need to recompute things on the fly, then of course no calculated columns, because they only recompute when you refresh the model. But actually, as you can see, and this is what you do in advanced scenarios, that you can actually use both. So here I have a measure, but this measure uses a DAX calculated column. And this is the beauty of DAX, right? You can mix pre-computing and interactivity and dynamism of DAX measures. Okay, so let's move on to other business cases, which are less advanced, but very interesting. So here I have a year-to-date calculation, but as you see, my calendar table goes up to December 2024, but unfortunately my actuals, my sales, they stop in April. So this is very annoying, because then my year-to-date by default, let me show you again the measure. My year-to-date here, it repeats the same value for every month, even the month with no transactions. This is not a mistake from Power BI. This is totally understandable. It sums up 0. Okay, this is the year-to-date calculation. So we need to find a way to stop the year-to-date at the correct date. And most of the time, what people will do here is that they will try to do some complex if statements in order to retrieve what is the last date and if and so on. This is very complex, and this can have a very bad impact on the front-end performance, on the performance on the report. One better way to handle that is to leverage the beauty, the power, the flexibility, and the easiness of DAX calculated columns.
Yep.
So how do I do that? I go to my calendar table. Okay. I'm going to add a new DAX calculated column, which is going to be a flag. So again, very low cardinality, false or true. And I'm going to say flag before max transaction. And I'm going to say, is the date of my calendar table, so row context, inferior to the max of my fact table. So by doing that, I can flag, I can pre-compute in my calendar table for each date, is it before or after the maximum transaction date? So of course, after April, it shifts. You're gonna see it here. You see the DAX calculated column. So here it's true, 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 and then false at this date here. So I can easily pre-compute, is it before or after the max date? And this is something that you should always do in your mind. Like when you have a complex calculation, does everything need to be recomputed on the fly in DAX measures? Not necessarily. Here, it's just a flag that I can pre-compute. Am I before or after the max transaction date? And then what I can do again a hybrid measure. I'm going to create a measure which leverages the DAX calculated column that I've just created. V2 equals calculate total sales, calculate table, date year to date, date, and then my flag. That's it. By doing that, I have a correct year to date, which behaves perfectly as I expect. It returns good results, you're going to see in a sec. And I can manage the way of stopping my year to date without doing if statements in the front end. I only do it in the back end. Okay, let me actually, it's so annoying, this default behavior. Okay. So here it's working. I have my correct year to date, but it stops. And let me drill down at the date level and go to April. Yeah, it stops here, unlike the default year to date. So again, very interesting. I am pre-computing a flag in my dimension table. Okay, I didn't plan to do this, but let's do it. Actually, if I go to DAX Studio, I think if I refresh the metadata and if I rerun the view matrix, probably that this column will show up. Yes, it's here. Cardinality 2. Mm-hmm. What is the impact? See, there is not even enough decimals in DAX Studio to say how much it represents. So it gives you an idea of no impact yep. on the dataset size. Okay, but very good impact on the, like here, not necessarily the performance. Here the performance I guess will be the same, but more about the behavior of how your DAX behaves in terms of calculations. Okay, let's keep going. Unless maybe Reid, you have a comment on this thing?
Well, and can you go back to your triangle just for a second?
Yep.
I would say, like, if I was to actually rank the three of these things, both in terms of what's needed most for consumers and also just what costs the most money, like data model size is at the bottom of my list. Like front-end performance is first and foremost the most important. The reports are meant to be looked at. So regardless of anything in the back end, you need a fast report. Secondly, in Fabric, the thing that you pay for is how much compute is being used. It's CPU and memory. It's not storage. Storage is the cheapest of all three. So if you have a 500 megabyte file that is very fast and efficient and uses very little CPU, very little RAM, it's not going to cost you that much. You need a lower Fabric capacity. If you have a 100 megabyte model but uses a ton of CPU and compute, you now need to pay for a larger Fabric capacity. So yes, you do want small model sizes, but I'd argue that like front-end performance, first and foremost, is the most important because that is what your audience is the only experience that they have. Regardless, it should and needs to be fast. Secondly, you want a performant model that uses a little cost. And then thirdly, ideally, then you also have the data model size. But that's where you basically have the rank there. But that's how I would definitely bucket those in. So you want all three in a perfect world, but in your order that you listed is where you should focus your attention on like optimization if you had to pick with any of those.
Completely agree. And one thing we could add on this, that makes perfect sense. I completely agree with you, and that was a nice addition to what I said. And also another thing that we could add, it's obvious, but we have to say it. This and this, it's totally invisible to the users. Like they don't see it. So I mean,
they don't know or
first,
care.
Yeah, optimize what they see, and then maybe optimize what they don't see. But yeah.
Yep.
Okay, let's do a couple more examples, which will be interesting as well. So I said at the beginning of this presentation that DAX was cool in order to leverage the data model and do what I call them inter-table calculations. It's when you need to reuse columns or calculations coming from other tables. So let me show you another great business case, which is very common. This is a dynamic segmentation. So here, if you remember at the beginning of this live, I have created this, but the criteria for my group was static. Okay, I said below or above 500. Now let's go a bit further. I have a hidden table which tells me how I'm supposed to break down my customers based on start and end, like intervals. And this could be an input coming from the business, from an accountant or whatever. And this could change, right? You could actually change the way you want to split your customers group, right? So what I want to do is that I want to bring in this customer importance into my customer table in order to classify my customers based on this table. If I had to do this in Power Query, it's totally doable, but I would need to have one row for each part of the interval and do joins and stuff. Maybe I will show you at the end as a bonus if we have time, but this is quite difficult to do that with Power Query, right? There is another method which is called conditional join, but again, not straightforward and not that performant. So what should I do? Shall I wait for my IT 6 months before they implement it in SQL? No, I'm gonna use DAX. So how I'm gonna do? I'm gonna use, so let's assume that we do this segmentation on the same KPI, which was the year-to-date sales. This is just an example. Of course, you might have different business rules, but I'm gonna say the customer importance. And I'm gonna say, okay, first I'm gonna store the measure, like the KPI, sorry, var, the KPI I want to break down. So this is gonna be my measure, total sales year to date, return. And then what I'm gonna say, I want to get what is the bucket, like what is the customer importance. And to do that, I need to apply a filter by saying, I want my year-to-date sales to be superior or equal to the start of my segmentation and inferior to the end, strict, because the way my intervals are bid, it needs to be strict. And where is it? It's here. So by using this DAX code, I can easily bring in, oh, did I make a mistake? Let me, oh yeah, here I should have put the variable, sorry for that. That's the risk of coding everything in live. So now we go. So here, without doing any joins and complex stuff before, even without any relationships, I can actually use the power of DAX Calculated Columns with this code in order to bring in the customer importance into my customers table. So this is the same use case classification because I want to use this customer's importance as a way to filter and break down my data. Yes, you can do it in SQL. Yes, you can do it in Power Query, but actually doing it in DAX is most of the time faster, easier. And again, I'm not gonna show it again because this is the third time. I think you got it. What is the cardinality of this column? 3, which is nothing. No impact on the dataset size and no impact on the dataset processing time either, because this code is quite fast to compute. But now again, because this is a DAX calculated column, I can actually use it in order to filter my data and combine the beauty of DAX measures and my columns in order to have an interactive report. So this is
Now
just
imagine
an
if
example.
they ever someday because well, one of the restrictions, of course, with any column is that it generally it only refreshes with a model table or more of a static refresh. But in a nice like utopian future, if considering all the features that they've had with like composite models and other stuff, it would be nice if they someday were able to somehow have like a special type of DAX column that could magically update or something. That's my hope and dream someday for something like that as well.
Me too. And you probably know that we had some discussions with Microsoft about that, but yeah, we told them, please do it. Like dynamic.
Well, obviously it's an expensive thing, especially in big models. Like you could probably do it on a table that's 100,000. I doubt that would be something that could ever be performant on like a billion rows. But you know, it's something that's it's nice to have on a wish list. But having any kind of actually dynamic column would be amazing.
Yeah, but actually in this case, I'm not going to show it today, but there is a pattern, you know, with the disconnected table where you can actually implement dynamic classification by only using a measure, you know, but it's quite more complex.
So yeah, because if you want a hierarchy of like high sales customers and a list of customers low, yeah, you have high, medium, low, as you said, disconnected table. The customers go inside of that, and then the measure itself tells you which one it shows and hides. But
it's
a little
really
expensive,
complex to code and not always performant. Yeah.
Oh, I agree. Yeah,
okay.
100%.
Reid, I still had how much time do we have left? Because
we have an extra half an hour buffer, so feel free to show the other two examples.
So I have other cool examples. I'm actually having so much fun now. I love DAX so much, you know, I could spend hours on this. Okay, so let me show you another example, which is pretty cool as well. So far, we have worked a lot on the customers table. We did the group, the importance and stuff. Now let's investigate a bit more about the stores. So here I have a dimension table, which is much smaller, which tells me this for each store, like the name of the country and so on. This table is linked to the sales table through the store key. One of the common business problems that we face sometimes at our clients is that they want to compare the trend of each store, even though stores have opened at different dates. So, for example, if I go here, so I have this chart where I'm comparing two stores, the store 200 and the store, so these are store codes, okay, 200 and 210. So as you can see, these stores did not open at the same date, like the store 200 opened here and the store 210 only opened here. But sometimes, especially in marketing and sales, they would like another kind of analysis which says, I want to compare the trend of each store X month after they opened so that I can compare, like they're on the same axis. So guess what? Again, we're gonna leverage the power and the beauty of DAX calculated columns. So how do I do that? Again, same technique. I'm going to pre-compute using the same technique as the customers. I'm going to pre-compute the open date. Do we say open or opening date in English? Reid? Open or opening?
I'd say you'd say open date.
Open date. Okay, sorry. So open date, I'm gonna say calculate mean order date. Sorry. So I get again context transition. I'm in a row context. I want to retrieve data coming from the sales table. So here I pre-compute so here I'm making a business assumption. Like my business assumption is that the first transaction of this store is actually the open date. Maybe it's different in your case, but that's just an assumption, okay? So here I can see that some stores have different dates. So for example, Lee stores, the two that were on my chart just before, they have 3 years difference. But still, I want to compare them on the same axis. So here I have pre-computed the open date. Now I'm going to go to my fact table, and I'm going to do actually a bit the same as before. I'm going to retrieve this pre-computed, let me clear the filters. Yeah. So I'm going to add a new column. And I'm going to count the number of months between the transaction date and the open date. So how do I do that? Number of months. Okay, let's call it like this. So var, this is going to be my transaction date. It's going to be order date from my fact table. Then I'm going to retrieve, using the model, the store open date from my dimension table. Again, same technique. And then return date diff. This is a DAX function that we haven't seen yet in this session, but this is a very nice function which allows you to compare intervals and dates and stuff. So date diff between the store open date and the transaction date in month. Okay, this is a business rule. I could compute it by days or by year, but I want to do it by month. But I could do it differently, okay? So here, yes, I am adding a new column to a fact table, but again, the cardinality of this column is quite small, right? There are not so many month difference, okay? What is great is that now I can use this DAX column. Actually, a best practice, I'm not gonna do it here, would be to hide this column and probably to create a specific dimension so that I don't use any column from the fact table to filter and so on, but I don't have time to do that. I'm gonna do it a bit the hard way, let's say. So actually, I don't want to compare by date, but I want to compare by number of months. And there we go. This is so insightful. So what is the business logic now? Let me zoom a bit. So what this chart is telling me is that 20 months after they opened, this store made this turnover and this store made this turnover. Actually, that would be actually maybe, yeah, I should do a null to date, or if I want it to be cumulative, but that would be even better. I will do it at the end if we have time, but at least here I can see the trend, and I can compare on the same axis what is the trend of each store X month after they open. This is very insightful. This is a very nice analysis. And of course, some people might say, yes, but Tristan, since you have used the DAX calculated column, this is static. No, it's dynamic. I can recompute it by brand, by anything, because I am using a measure here. What I'm measuring is the total sales, but the way I break down the data, it's by using the DAX calculated column, which is fixed. Like, what is the difference between the open date and the transaction date? And that's it.
Yep.
So again, very cool example where, yes, you could do it in SQL, in M and stuff, but I did it in DAX. Low impact on the dataset size and backend performance. Very good impact. Here, the good impact is not really about performance, but it's just about insights. Like, I provide insights to my business users, right? Any comments on this or questions? I don't know.
Just a comment from Donald, like a ribbon chart could be useful on this one, just to see when essentially they overlap each other.
True.
But yeah, end of the day, it goes towards functionality and performance from the front end. So, you know, any back end magic that you have to work just to make the report experience better and the insights more practical and useful. Like I will always default to focusing on front end first and foremost,
Yep,
while
agree.
minimizing, you know, complexities and in, you know, in um any duct taped solutions in the model.
Yep. So if I want to do very quickly the cumulative, I would probably do it like this. This is totally improvised, okay? Hopefully it works. But yeah, I don't know if it's gonna work, but just to have the, you know. Okay. Any other questions before I move to the last demo?
No other questions. Just you know, some comments on very creative and and a few others, but otherwise, yeah, I think you're good for the next one.
Great. So, okay, my measure didn't work. I will explore. Okay. So now this is a more complex example, but it's very interesting. So I talked about inter-table calculations, like bringing things from here to here, or from here to here, or we saw like DAX calculated columns allow you to navigate through tables. But actually, DAX also has a hidden gem. It's very good for what we call inter-row calculations. So sometimes, let me explain. For example, when you add, there are two types of columns. There are some columns where the result only depends on the row that you are scanning, actually. So this is what I call intra-row calculation. So the result only depends on this row. But sometimes you have much more difficult patterns where you need to travel vertically in the table and you need to retrieve data in the past for a given customer. So for example, let me give you a first example. In the stores table, in the sales table, you know, when I computed the number of months difference, that I had this store open date. What I could have done, that would be less good in terms of performance, but just for education purposes, I want you to understand this concept of vertical travel and inter-row calculation. I could have done it this way, store open date. So here I'm in the fact table, okay? And I'm gonna say calculate mean of order date, all except, okay? So all sales except store key. So by doing that, I am moving vertically in the table. So let me explain. Let's take the example of this store. Okay, let's take this store. So as you can see, this store has many transactions on different dates, okay? But what I needed to do for my pattern is that I wanted to fix once and for all, for every row, I wanted to know for every row, for this particular store, I wanted to know what was the minimum transaction. So actually, I am moving vertically in my table. I need to retrieve what was the first transaction. So for example, when I'm here, I want to retrieve this value. And this is what I call vertical travel or windowing or inter-row calculation. And this is sometimes a need from the business. Here, that could be an example where you need to retrieve data coming from previous rows, actually, or stuff like that. And it's not easy because you are not in Excel, right? So you don't have a row by row or cell by cell calculation logic. You need to work with the context and stuff. Okay. So this is what I call vertical travel. My last example is this. Sometimes, okay, let's take a customer. I'm gonna take, okay, let me remove the filters. This is gonna take 3-4 minutes, and then we will jump to the conclusions.
Oh, yeah.
So customers, okay. So here I have a customer which has different transactions. And let's assume that I want to compute the purchase frequency. Like I want to know, like on this date, I need to know what was the previous transaction date for this given customer so that I can compare the number of months between each transactions. Am I clear? Yeah?
Yep.
Okay, so basically for every row, I need to know what is the last date. For example, I need to move here. For this one, I need to move here. So I need to retrieve data coming from other rows based on the same criteria, which is the customer key. So this is what we call windowing or inter-row calcs. Okay. Yeah. So to do that, I'm gonna leverage the power and the beauty of DAX, because for this kind of pattern, it is much quicker and easier actually to do this in DAX rather than Power Query or M. Actually, I'm gonna leverage the new window functions which were released a few years ago by Microsoft. So this is quite a complex one, but it's totally worth it, both in terms of performance and convenience. So first, what I need to do is that I need to retrieve what was the last transaction date for this customer. Last transaction date. So as I said, there is no in DAX or in Power Query or whatever, even in SQL, there is no concept of previous row. Like I cannot point to the previous row, okay? Maybe I can do it with visual calculations, but here I need to implement this logic at the model layer, not at the visual layer, right? So that I can reuse it and stuff. So to do that, I'm gonna say, be careful, this is a big one. Mean, so I want to retrieve the mean of the order date, okay? Then I'm gonna say offset, so this is a new window function, offset by 1. Order by, so this is what is the grain at which I want to do this calculation. So I want to do it at the customer level. So it will be my customer key. So this is the equivalent of all except. Like I say, at which grain do I accept this calculation to be computed? Oh, sorry, no, order by, it's actually the date. Sorry, it's partition by. So dates, sorry, dates. Yep, and it will be ascending. So this is how do I want to order my table. Then partition by, this is the grain. Sorry, I mixed it up. Customer key. Yep. That's it. Okay. And then because I have applied calculate, I'm going to say all sales because I need to break context transition. So this, even on a 2 million rows table, it can take a few sec to compute because it's quite expensive. But again, think about the impact. For this case, yes.
And also, like, I mean, that compute is happening at 3 a.m. when this model gets refreshed. The report users never see that.
Exactly. It's the same story. Here we are talking about the backend. So, and it works. So actually for this customer, you see that for the first date, there is no previous transaction. But then for this customer, there is a previous transaction, okay? Which was this one, yeah, 14th of July. And then for this one, so it retrieves dynamically, like for each transaction, what was the last transaction date. This is a very, very powerful pattern because as you can see, DAX not only allows you to use relationships and to bring in content from other tables, but it also navigates through the table. Yep. And it's very powerful. So of course, in SQL, you have the equivalent. And by the way, I think that Microsoft, when they implemented the DAX window functions, I am pretty sure that they were quite inspired by what the SQL engine does, because this I've been here for years in SQL. So yes, you can do this in SQL, in probably even in a better and faster and easier way. But again, you don't always have SQL. And Reid, I don't know if you have ever tried to do this kind of stuff in Power Query. This is a nightmare. Like you need to create an index and do a self join, and this is insane, right?
Yeah, the there again, it goes just back to the it depends. There, Matthew Roach's maxim will always come into play on like when it's easy to do upstream, do it upstream. When it but there's so many exceptions to that rule. Whether or not it's your ability to access upstream places to do it, or is it going to be 10 times harder? Like just leveraging relationships in a measure sometimes when it's going across 5 or 6 different tables that are coming from 6 different sources. One is a CSV file, the other one's a database, another one is Databricks. Something is doing all those joins and like in a database or in Power Query is just it's insane. Like, and you're going to end up with a very painfully slow process to do that versus writing a measure in 5 minutes, 10 minutes to do to leverage the shape of the model that's already there.
Yep. So while you were talking, sorry, I just coded I completely agree with you. So while you were talking, I just coded the output that I was expecting, which is, okay, now that I have retrieved what is the last transaction, now I can return how many months or how many days, here I'm doing month, but do I have between these transactions, and then I can do an average or whatever. Okay, so that was just an example to show you that DAX is also very interesting when you need to do windowing or inter-row calculations.
Yep.
I should have done it in Power Query and show you the difference in terms of performance and code. This is a nightmare. Like in Power Query, try to do that. It's very complex, very complex. Okay, so I'm done with my demos. Just for you to know, I have saved just for you to measure the impact. Okay, if I go here to my DAX calculated column demo, you can see that this is my final file. Okay, so this file, it's the file with all the calculated columns and everything. Okay, I have only increased by 10% my model by doing all the analysis I've shown you today, like 7, 8, or 9 calculated columns. But still, this 10% increase gave me such incredible performance gains and insights and easiness of calculations. Again, when you compare this, remember the first pattern? Try to compare this. Where is it? This one? It's pretty complex, right? With this one, not only it performs faster, but it's much easier, right? Because I have managed most of the complexity in the backend, in the calculated column. So just to conclude, that was quite a big session with lots of examples. You will have the replay, so you can practice. Maybe I can share the file as well if you want.
Please, so, yeah. People like, that's one of the first questions on every video is, can I access the PBIX? So if you have one where people can poke around in it, link me to your website where you host it, and or give me the file either or, and I will make sure to post this in the YouTube comments.
Great. So just to conclude, of course, if you can, do it upstream, SQL data warehouse, or even in Fabric now we have notebooks and pipelines and ETL. Yes, in a perfect world, if you know how to do it, and if you have access, and do it upstream, not only for performance, but also for governance, for purposes. But never say never. Never say never. Be pragmatic. Sometimes there are some situations where it's worth it. So always think about the magic triangle when making decisions about your model. As you saw in this session, DAX calculated columns can be a great weapon because they can leverage your data model. So when I say this, I mean the relationships, the measures, and they have, like we call, there is a concept in DAX what we call data lineage, right? So they can move across the model much more easily than Power Query. DAX calculated columns are easier to code and faster to execute compared to Power Query and M for inter-table calculations. So this is what I did, for example, when I brought in the customer segments from the disconnected table, or inter-row calculations. That was my last example. Last, you said it a bit earlier, Red. DAX calculated columns can also be used as a temporary and short-term solution. Okay, it's the same for low code. Like sometimes you build things in Power Apps or in Excel just because you need it now, and you need to understand the business logic. So you need to implement it somewhere, and then at some point you say, okay, maybe I need to industrialize this. So I'm gonna talk to IT, and they're gonna implement it upstream using SQL or whatever. But still, by doing this kind of DAX calculated columns, sometimes not only you fix your short-term issue, but also you make it easier for IT and data engineers to understand how, like, what is the underlying business logic and how they will then implement it in the backend, right? So
Agreed.
I think this is probably one of the best examples of DAX calculated columns. Maybe they will not stay forever in your data model, okay? Or maybe they will, and it's okay if you respect best practices. Okay, so that's it for me. I hope you enjoyed. I don't know if you have any other comments or questions.
Yeah, I'm looking in the chat now. So just basically some applauses, plus ones, a lot of really good demos and practical use sets, which I think everybody has appreciated. But I think a really good summary that I've seen on a journey is for people is day one, most people just everything calculated columns. They don't really understand measures. They don't know the difference. So it's, your year to dates, your actual to budget variances. They all just become extra columns in your fact table. Then you see an article that says, oh, no, measures, not columns. Okay, so never use calculated columns, only write measures. But then at some point you also get to that advanced level where you start to realize, oh, wait, I can even though I technically can do everything in a measure, it's horribly slow. Maybe I could do a bit of both and dance between those. So I feel like it's a journey that goes one or the other. Count columns only, measures only, and then kind of a hybrid approach of the two of them when and where it's necessary with all that stuff. But I think this is a good pragmatic approach to really just kind of understand if and when, because it is an it depends scenario. And, regardless of if it's in SQL, Power Query, or DAX, you should avoid too many extra columns in your model in general, but they are needed sometimes for certain things. Because to be technical on how Microsoft describes it, everything that shows up on a visual is an analytic query. It either summarizes, it groups by, or it filters. And whenever you need something to group by, meaning like an axis on a visual, or you need to filter, you need a column for that. So if you ever need either of those two criteria to be met, that's when an extra column in your model is needed. If it's only needed to summarize, then that's where you have measures. But it takes a bit of time, I think, to explain to people and have that like click in your brain of, oh, that's what I should do, this versus that. Like you learn it 20 times, and the first 19 times you have to keep looking at the article for it to make sense. And that 20th time, it finally just clicks as like something that actually makes sense versus you're just repeating what's written on a page. But that's a journey that everybody has to go through with this stuff.
Completely agree. Yeah.
Yeah, but this is good stuff, and I think this will be very useful. Hopefully, we'll get another 8,000 or 9,000 views on this after okay. A few years. But it's a popular topic that's very SEO, search engine optimized, like DAX and calculated columns. So I'm sure you'll get plenty of good views on this.
Yeah, and maybe read what we can tell to the viewers which are live or which will watch this after. Yeah. Share this to people who do not believe in DAX calculated columns. Show them the light.
Also, just as a mention, so like I have been talking to the Microsoft team because, as you said, just to keep it short, there's been discussions, you know, LinkedIn and other places on like whether or not you should use them or not. And there is, with some topics, I would say subjectivity. Like, you know, me versus Mike Carlo, we have discussions on like whether or not to use scrims, which is the background, having a frame in the background image versus adding a shape. I personally prefer to add shapes. He likes to have background images. That's also a subjective choice for the most part. But something like this, there is upcoming Microsoft documentation from the team that created DAX, manages the Vertipaq engine, that will say, here are use cases when you should use a DAX calculated column. So there are, and I don't know the list of it, but there are defined situations provided by the team who invented the engine to say this is when you're supposed to use that. So I would say to a degree, like, it's less of a discussion. No, there is just going to be Microsoft approved times when this stuff should be used, regardless of expert opinion. Microsoft is seconding the opinion on that.
Yeah, of course. And I hope I won't be too far from what they will say.
I'm sure most of what we've just talked about is, I don't think they're going to, I doubt they will go into the temporary fix things, but I think they're going to go from a performance perspective. This is when you should do this versus other situations. But I'm very curious to know when that's going to come out. I think it's in the next month or two, but it should be soon. We'll get some new documentation on that.
Great.
Anything else as we wrap up? Any closing remarks or anything?
No, I actually had so much fun doing this session. I wish I will do it also in French, maybe to my French community, because I love this session like DAX, and I'm having so much fun. So thank you for having me on your YouTube channel, Reid. That's always a good opportunity, and I hope people will enjoy and have enjoyed this session. Yep.
Absolutely, and I'll look forward to getting you back on at some point in the future as well.
Okay, thank you very much.
All right, cheers. Thank you so much for watching. Please consider hitting that like and subscribe button. And if you want to help support this channel, take a look at our channel memberships or our merchandise store for cool swag. And last but not least, please consider sharing this video on your social media platform of choice to help our channel grow. So, until next time.